Alright guys, today we are simplifying radical expressions. A radical is just a square root symbol. Now this is going to involve breaking down a number like we did on Friday. We did the factor trees and I showed you that little method that I like. We also are going to be looking at perfect square factors. Okay, and so what we're going to do right now is make a list of the first 15 or so perfect squares in our notes, because you need to be familiar with these. It's going to help when we do all kinds of things. Factoring, of course, for this lesson we need it. You got to be familiar with perfect squares. What is the first perfect square? 1 is the first perfect square. What is a perfect square? A square with equal signs. Okay. Edwin, it is not just a square with equal signs. It's a number that can be found as a product of it times itself. Like 1 times 1 is 1. 1 times 1 is 2. Ay. Alright, the square root of 1. This is why 1 is a perfect square. You can take the square root of 1 and get a nice whole number answer. What's the square root of 1? 1. Because 1 times 1 is 1. Alright, the next perfect square is 4. 4 is a perfect square. And actually, it can be written as a square, Edwin, if you want to give a geometric spin here. A perfect square literally means you can write the sides of 1 and 1, or 2 and 2, or 3 and 3, and the area would be the perfect square. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So yes, it does have something to do with perfect squares. Alright, what is the square root of 4? 2. What's the next perfect square? 9. And the square root of 9 is 3. Then 16, and the square root of 16 is 4. You keep going. You keep going till you don't remember them. Oh my gosh. You should be able to at least get to 10 times 10. After 16 is 25, and the square root of 25 is 5. After 25, 36, the square root of 36 is 6. After 36, 49, square root of 49 is 7. 64, square root of 64 is 8. Okay, I want you to have a list in your notes, though. I know you get it, but we need a list in our notes because this is going to come up on several lessons in your near future. After 81, the next perfect square is 100. Now, while you're finishing that list, think about the vocabulary here. Squaring and square rooting are inverse operations. So if I ask you for the square of something, that means you multiply it by itself. If I ask you for the square root of something, you want to find what number times itself equals that perfect square. For example, what's the square of 9? No. 81. The square of 9 is 81. What's the square root of 9? 3. What's the square of 4? 16. What's the square root of 4? 2. What's the square root of 36? 6. What's the square of 6? 36. So squaring and square rooting are not the same thing. Alright, you should be all the way up to at least 10 times 10. After 100, the next one's 121. 11 times 11. Then 144. 12 times 12. Then 13 times 13 is 169. The square root of 169 is 13. And then 196. And then 225 is 15. Now, these come up quite frequently. And it goes on forever. We could keep going by doing 16 times 16, 17 times 17, and sometimes those do pop up on you. These are the ones that you should be familiar with for sure. Another one that comes up quite a bit is 400, so I'm going to go ahead and add that to our list. I skipped a few. And the square root of 400 is 20. I skipped a few more, and another one you will see quite a bit is 625. The square root of 625 is 25. Okay, so just keep this list handy. You're going to need it when we do difference of two squares. You're going to need to be familiar with the first several perfect squares. And today what we're looking for is perfect square factors. We want to find factors like 4 and 9 and 16 and 25 and 36. Because we are simplifying. Finding a factor of 1 really won't help us, but technically 1 is a perfect square. Okay, so if I asked you to give me the square root of a perfect square, that's super easy. But guess what? I'm not going to ask you for the square root of a perfect square today. Can I erase this? Alright, if you didn't finish, it will be on Schoology. Alright, we are simplifying today. Wah, wah, wah. Alright, simplify. We're going to simplify something like the square root of 20. 20 is not a perfect square, is it? Now, we should be able to give a pretty good estimate. We should know what two numbers it's going to fall between. It will fall between 4 and 5, because 4 times 4 is 16. That's a little bit too small, and 5 times 5 is 25. That's too big. It's not exactly a nice 4.5 either. If I wanted you to give me an estimate, I'd have to give you a calculator. If I wanted an estimate that was better than between 4 and 5. Right now, the only thing you can tell me is it's between 4 and 5. Give me a second, please. Stop talking. Alright, square root of 20. Now, the calculator ran out of space. This really goes on forever. But that's a good estimate right there. That's not exact. Is it between 4 and 5? Yes. Now, that's not our task today. We're not worried about that. I just want to show you how you can kind of check your answer if you want to. Square root of 20. We're going to write it in a different way. We're going to write it as a product. And we're looking for any perfect square factors that are hiding in the 20. So this is where that break it down comes into play. This is where that factor tree comes to play. You need to break 20 down. If you like the factor tree method, then do it that way. If you like the way I did it, somebody named it the wedding cake method today, which I like that because it does kind of look like a wedding cake. That's the way I'm going to do it. I always start with the lowest prime number that goes into 20, which is 2. Remember we did this Friday. 2 goes into 20 10 times. 2 goes into, I keep dividing by 2 till I can't divide by 2 anymore. 2 goes into 10 5 times. As soon as I hit a prime up here, I'm done. So 20 breaks down to 2 times 2 times 5. Do you agree with that? So we could rewrite 20 as 2 times 2 times 5. Because what is 2 times 2? And what's 4 times 5? Okay, now, here is the deal. You are looking for pairs of numbers because a pair makes a square. A pair of factors makes a perfect square. Do I have a perfect square here? I absolutely do. Do I have a pair of numbers? I have a 2 and a 2. Go ahead and multiply them back. What is that? Isn't 4 a perfect square? Okay, so now I'm going to rewrite this as the square root of 4 times 5. Don't you agree 4 times 5 is 20? And don't you agree 4 is a perfect square? So I have found the only perfect square factor that was hiding in the 20. It's a 4. Now this square root symbol is being applied to both of the numbers underneath it, the 4 and the 5. Well, one of them is a perfect square. I'm going to go ahead and perform that operation. I'm going to do that math problem. What is the square root of 4? 2. So this is going to come out. The square root of 4 is not going to be in there anymore. 4 is a perfect square, and the square root of 4 is 2. The 2 is now outside the symbol, and anything that was left inside, you multiply it back. I only had a 5 in there. So the square root of 20 is the exact same expression as 2 times the square root of 5. Now, if I wanted to make sure that that equaled 2 times the square root of 5, I'm going to do it in my calculator. 2 times the square root of 5. I get the exact same answer because those expressions are equal. They're equivalent. All I did was I figured out if there was a perfect square in there, and I went ahead and simplified that part of it. I took the square root of 4. Okay, what this is we're gonna learn a method called completing the square, which allows us to find roots of quadratic functions. So this is like a little baby step of something that we're gonna learn eventually. All right, let's try another one. Square root of 45. Now, my little wedding cake method, I always start with 2, 3, 5. I start with the smallest primes that I can. Can 45 be divided by 2? Can it be divided by 3? Yes. 4 plus 5 is 9, so 9 can be divided by 3. That means 45 can as well. So 3 goes into 45 15 times. Can I keep dividing by 3? 3 goes into 15 5 times. I've got nothing but primes left, so I'm done with the prime factorization. Did I find a pair of factors? Every pair makes a perfect square. So what perfect square did I find? 3 is not the perfect square. 9 is the perfect square. This pair, put them back together, is 9. Isn't 9 a perfect square? Okay, so do you agree that 45 is the same thing as 9 times 5? Now, that square root symbol goes with the 9 and with the 5. One of them gets to come out. One of them's perfect. So the 9 is going to be square rooted. What is the square root of 9? 3. So now it's on the outside of the symbol. What stayed on the inside? The 5. Now, if I want to make sure that those two expressions equal each other, I'm going to do the square root of 45. And I'm going to do 3 times the square root of 5. And I do get the exact same amount. Okay, this isn't necessary. This is just me proving to you that those two things equal each other. Your answer would be this. Okay. Where did I get the what? Where did I get the 9? Because every single time I find a pair of factors that are exactly the same, that makes a perfect square, and I multiply them back. Because I chose to... If you don't like my little method right here, maybe you want to go back to the tree way. Give me 2 factors of 45. 9 and 5. That's prime, circle it. 9 breaks down to 3 times 3. How do I get the 3 outside? Okay, so you agree that 9 times 5 is 45, right? Well, basically, this square root symbol, it's like taking the square root of 9 times taking the square root of 5. What is the square root of 9? 3. I went ahead and performed this operation. The square root of 9 is 3, so it came out in front, and the 5 had to stay in there because it's not perfect. Only the perfect ones get to come out. All right, try this one. Square root of 180. Right now, I want you to break down 180. Boys, stop. My method, I always want to start with 2, 3, and 5. Usually most things can break down to 2s, 3s, or 5s. Start out with the smallest one. If it's even, you know you can divide it by 2. And you keep on dividing by 2 till you can't anymore. Then you try 3. If 3 won't work, you move on to 5. If 5 won't work, you move on to 7. Okay, until you have it broken down to nothing but primes. 2 goes into 180 90 times, right? 2 goes into 90 45 times. I can't divide by 2 anymore. Try the next number, which is 3. Can I divide by 3? 3 goes into 45 15 times. Can I keep dividing by 3? Alright, now I have nothing but primes. So 180 becomes 2 times 2 times 3 times 3 times 5. Do you agree with that? Now, please watch this part carefully. There's more than one way to do this. Every pair makes a perfect square. So what perfect squares have I really found? 9 and 4. 2 times 2 is 4, and 3 times 3 is 9, and then the only thing left that's not perfect is the 5. Now watch what's going to happen though. Everything I take out is going to go to the front of the radical symbol. And if I take out more than one thing, you got to multiply everything that you take out. I'm going to take out the square root of 4. What is the square root of 4? 2. So just imagine there's a 2 hanging out here. The 4 is gone now, and it's now outside because the square root of 4 is 2. What's the square root of 9? 3. Well, there was already a 2 out there, and now I brought out a 3. So what's really out in front now? 6. Because these are factors. Factors are part of a multiply problem. So I took out a 2, I took out a 3, which joined together to make a 6 out in front. What stayed inside? 5. Yes. You don't need a calculator to do 2 times 3. Oh, how do you check it? You really can't. Right. Now, let's back up a second. Let me show you a different way. If you don't like taking out 2 things at a time, what you can do is any 2 perfect squares or 3 perfect squares, if you multiply them back together, they make an even bigger perfect square. So I could have gone ahead and multiplied the 4 and the 9 back together. What's 4 times 9? 36 is just another bigger perfect square. What's the square root of 36? 6. And what stays in? The 5. I get the same answer at the end. You could take it out one at a time, or combine them all into one giant perfect square and take it out once. Yes. The square root of what? No, it's not 6.5. The square root of 180 is the same as 6 times the square root of 5. Okay, so if you wanted to check it, you would do the square root of 180. And this is saying 6 times the square root of 5. That should give you the exact same amount. And it does. This is the answer. The directions are just to simplify. You're not telling me what the square root of 180 is. You would need a calculator to do that. What we are doing is rewriting this in a different way. We're rewriting it in a way that's exactly the same amount as it. But we want to pull out all the perfect square factors that we can. All right, you try this one, please. Square root of 120. Simplify that. And if that little wedding cake way is not working for you, then just go back to the tree method. Some kids like the tree method better. The thing I like about the way I do it is it puts them in order. And as long as you always start with the smallest thing and then move on to the next smallest thing, it's going to keep them in order for you. It's easier to recognize pairs of factors. Okay, let's talk about that. 120 divided by 2 and you get 60. Divide by 2 and you get 30. Divide by 2 and you get 15. I can't divide by 2 anymore. Divide by 3 and you get 5. Now every pair makes a perfect square. So one of those 2's is out of luck. One of the 2's is going to have to stay behind. These 2 become a perfect square of what? 4. Were there any other perfect squares in there? No. So 120 is the same thing as 4 times 2 times 3 times 5. Well, the only lucky factor in there, the only perfect square factor was a 4. It's the only one that gets to come out. When it comes out, what does it come out as? 2. Now, anything that was left inside, you multiply it back. So what's still inside? Which is what? 30. 2 times 3 is 6, and 6 times 5 is 30. That's my final answer. Can't you square 30? 30 squared would be 900. Can't you square root it? Well, the only factors of 30 are 2, 3, and 5. None of those are perfect. 30 doesn't have any more perfect squares hiding in it. So we're done. All right, try this one, please. Square root of 108. Well, we're going to do a lot more. I have no idea. Current event, maybe? brother as a sub? What? Oh. Alright, Fernando, what did you get for 108 when you broke it down? Then stop talking. Andrew, did you break down 108? Okay, well, don't just sit there. You can start somewhere. 108 is even, so what can you divide by if it's even? Okay, and if you still get an even number, keep on dividing by 2. 2 goes into 54 27 times. Now I need to move on. 2 won't go into 27. It's not even. But 3 will. Okay, so 108. I am seeing 2 perfect square factors. What are my 2 perfect square factors? 4 and 9. And then the only thing left over is 3. Now you can either take out the square root of 4 and square root of 9 separately. But just remember, you got to multiply those totals when they go out front. Or combine 4 and 9 together to make one giant perfect square of what? 36. And then just take the square root of 36. It's up to you. Either way, what you end up with out in front is 6. And what stays inside is a 3. A 2 comes out here, a 3 comes out here, and you got to multiply those. You get 6. Or rewrite this as 36 times 3, because 4 times 9 is 36, square root of 36 is 6. Either way, you're going to get a 6 out front. Alright, last one like this, and then we're going to move on to a different type of problem. Square root of 800, go! This is not the last problem we're going to do today. Add negatives, that's a good idea. What now? It's not 800 is not a perfect square, no. But it does have some perfect square factors. More than one perfect square factor. Okay, this is how you check to see if you can divide by 3. Add the digits together. Okay, what's 2 plus 5? Can 7 be divided by 3? Then neither can 25. Andrew, are you breaking it down? Don't have a breakdown, just break it down. Okay, well, let's see. 800, I definitely can divide by 2. I get 400. I definitely can divide by 2. I still can divide by 2. I still can divide by 2. Still can divide by 2. Then I can't divide by 3. I can't divide by 2 anymore, or 3 by 5. Every pair makes a perfect square. So, what are my perfect squares? 4, 4, 25, and what else is left over in there? That last little 2. No. Okay, what is the square root of 4? 2, so I'm going to bring a 2 out. What's the square root of this 4? Also a 2. What's the square root of this 25? So I brought out a 2, and a 5. What is that? 20. What stays in? That lonely little 2. Or you could have multiplied all these 3 things back together. 25 times 4 is 100. 100 times 4 is 400. And 400 is a big old perfect square. Guess what the square root of 400 is? 20. Yes. Yeah, everything, when it's still in here, it should always equal a product of 800. Okay, now, the only extra little thing you're going to have is some of your problems will already have a number out in front. But it's okay, guys. It's just one extra little thing. Calm down. What's happening here, it's almost like somebody started to simplify it but didn't find all of the perfect squares. They left some back behind. So they took the square root of 25 and got 5 out to the front. So whatever else comes out just gets multiplied by the 5 that's already out there. So that's the only extra step. Whatever comes out, it's already got a number out there that it's got to multiply by. So still start with 60 and break it down. Go, break it down. Okay, just pretend like the 5's not there for a minute. Just do the 60 like we've been doing. Hush. Were there still some perfect squares hiding in there? Or a perfect square hiding in there? Okay, so what perfect square was still in there in the 60? 4. 4 times everything that's left over. Times what? Times 3 times 5. I'm going to go ahead and put those together and make a 15. Yes. Now, what is the square root of 4? 2. A 2's got to come out and multiply by what was already out there. Now I have a 10 out in front, and inside I still have 15. Yeah, when the 4 comes out, listen carefully, it doesn't come out as a 4 because you're doing the square root of 4. The square root of 4 is not 4. Are you listening? Are you listening? The square root of 4 is a 2. It comes out as a 2, not as a 4. Alright, try one more like that. Okay, it is fun. Alright, try that one. This is as far as it's going to go. This is the top notch right here on this assignment. Guys, calm down. Okay, now I found 2 perfect squares hiding in there. Hopefully you did too. 4 times 9 times 5. Remember, every pair make a perfect square. 2 times 2 is 4, 3 times 3 is 9, and then we have that lonely 5 left over. Now, there's already a 3 out here. It's going to multiply by whatever happens when I take the square root of 4 and the square root of 9. What's the square root of 4? 2, so a 2 is going to come out. What's the square root of 9? So a 3 is going to come out. So I have a 2 times a 3 times a 3. 18. What stayed inside? That's my answer. Alright, your homework is page 401, 11 to 25, all of them. That's 15 problems. You can do it. Get busy now. It's not going to take you all day. We just did several problems in 20 minutes. Page 401, 11 to 25, all of them. Get busy right now.